Hi folks, so we're live. Thanks for tuning in, and apologies for again for the delay. My VR rig has given me a blue screen of death, and it's just I don't have time to fix it right now. So I'm running on a backup laptop. The problem is this personal laptop doesn't have any VR capabilities, but we should be able to still go through the code, and we'll work it out from there, because I don't want to skip this this session. So it's just a shame I couldn't show you the slides that I've prepared for this. But a good thing is that I've have some stuff already laid out here in the Livestream GitHub repo. All right, so I guess we'll start and just double check that I've got everything all set up. So please bear with me, because I have got only one screen on this laptop, and I want to make sure that we're actually broadcasting. So let's see. All right, so let's go to, I'm just gonna open up Twitch and see that we're live. And of course, all right, so while that's running, I'll go ahead and go through what we're going to go through today. So we're gonna go through upgrading UE projects from 4.17 to 4.18. And I'm not 100% sure. I still have 4.18 preview in this machine, and we're gonna do line tracing, interfaces, tags, delegate events in C++, and creating components. All right, so okay, so we seem to be live, and I'll keep that in the background for the chats. All right, so let's get started. I've downloaded I've cloned this on this machine. Everything's newly set up. Dang. I'm just gonna have to find the live stream. And all right, so what do we need to do an upgrade? So the main thing to do an upgrade for Unreal Engine is to simply right-click on your UE project file, and then you should have something like this: switch Unreal Engine version, and just switch over to 4.18, and then click OK, and it should generate the project files and do another build. Let's see once it's up and running. And you could show the log. So for mostly Blueprint projects, this should work in most cases without any other configurations. But if you're doing a C++ project, there may be some changes in the code that's required. So for our project, we've done really basic C++ code, so we don't really need, I don't foresee any issues of doing the upgrade. But you could see here that it generated a new solution file. If you already have a solution file here, you could do right-click, generate Visual Studio project files. Let me just do that. So it's always a good idea to regenerate it, especially during an upgrade. Alrighty, so I'm gonna open up the solution file now. So For those just tuning in, I'm running on a machine that doesn't have any VR capability because my VR rig around 10 minutes ago just gave me the blue screen of death just when I've got everything prepared. So I'm just running on my backup laptop at the moment, so some stuff might get a bit messy, but we'll get there. So important thing is I want to be able to show you all of the technical stuff that we need to cover for this live stream. All right, so we've got the source code here, and everything seems to look good. So I'm gonna rebuild Livestream VR here. And I don't have most of my C++ Visual Assist on this machine, so I'm gonna do it all manually, which I guess is gonna be useful as well for everyone. It's just gonna slow me down a bit because I have to type everything in. So, and of course I have to remember them, but let's see. Should not be a problem for this. So it's gonna do some building here. And what I want to do while that's happening is gonna just show you what we're going to do. So in my plugin out in the marketplace, so if you go to, let me see which one is the right link, this one. So out in the marketplace, I've got a VR plugin that you can install onto your projects, which gives you a lot of pre-configured, gives you a pre-configured VR pawn, and allows you to do a lot of common stuff that you do in VR, so that you can go ahead and do mostly just game logic or some of your experience logic in VR instead of having to redo them each and every time you create a new project. So we're gonna focus on this one to the gaze component. So we're not obviously gonna be recreating the entire gaze component in this the span of this live stream, but what we're going to do is reproduce some of the core code for this that I use in the gaze component, so that either you can use that or use the component that comes with this plugin. It's free, with the code also available in GitHub. Or yeah, you could modify it so to suit your project's needs. So it allows you to be a little bit more granular since you're creating it from scratch. All right, so let's see how we're faring with our, I'm just gonna close the launcher. And all right, so that's still building. And we're gonna just go ahead and, go ahead and have a quick look at the plugin here. So this came up, the reason for this is I was doing a game jam. I think that was one of the epic game jams, and one of the mechanics that we wanted to do was if you stare at a door like this, then it we wanted, like, when you're staring at the door, it slowly materializes into the world, and once it materializes, then it teleports you through that door. So without having to move, because we didn't want a lot of movement for this game, for this game jam entry. The idea was that the player is, well, blind, so blind in VR. But yeah, I thought it was a pretty cool concept. We didn't win, but yeah. So you could see here how to actually set up the plugin and what you can do with it. So there's a couple of nifty variables here that you could change. So you could change the spawn size and spawn rate as well. And this is a little bit outdated. You can also, from the requests from you guys, you folks, you have, you wanted something like target static mesh. And then you want that target to kind of rotate and face you. So there's now a tick box there that allows you to do that relatively easily. And the code is available. All of this code, all of the sample code is also available in GitHub. So I'm just gonna open a new one here. And yep, so from here. So this one is the one with a demo project. So if you download this and then run the U project, you've got version 4.18 here, and you should be able to run this code. Okay, with the what I'm sampling here in the YouTube video. And if you want to go through different versions of the engine, it's available in 4.16, 4.17, and 4.18. It is available since 4.12. An earlier version is a non-plugin version is available since 4.11 of the engine, but I've only placed things in GitHub when it got published in the marketplace. So you've got 4.12 to 4.18 now. Yeah, but I'm only supporting 4.16 to 4.18 for new stuff that comes in, because obviously it's a little bit difficult. I'm basically alone on doing this project. So although I really appreciate some of the contributions that I've got from some people. So you got Recidal, Banana, and Big Toe 663. Thanks guys for helping out a bit. So and if you have any code that you'd like to contribute, please do so. So really appreciate that. All right, so let's see how we're doing. So that built. So if you do get errors, then you have to fix it, because sometimes the C++ functions do change from code base to code base, or sometimes you would have to do some stuff on your Livestream VR, or sorry, on your build.cs file. So once that's built, for the upgrade, I'm just going to open up the U project file, which I'm unfortunately on preview 4 on this machine. So we're gonna have to not commit any code and have to redo this once I've got my VR rig up and running, so that you get a nice 4.18 version, a proper 4.18 release version. Okay, so I'm not gonna do any commits on the repo for this stream. All right, so that should come up fairly soon. Let's see how we're doing. So if you're wondering where it is, I'm just gonna remove this now. I've tried not to advertise this stream too much until I get to a really stable system, but so far I thought I was already on that stable system, and then my machines got nuked like 10-15 minutes before I wanted to do this. Yeah, so but these things happen, so we're just gonna have to work through with it. Okay, so I'm just hoping that this machine doesn't do the same thing at some point. So I've got 39%. I've got a higher resolution on this screen, so I hope that that reflects nicely anyways onto recorded videos. Okay, so while that's going and while we're waiting for that, let's go back to their live stream. So one of the things I wanted to do, because from the last live stream I've got Flight, and then we did Google Earth, something like Google Earth VR or Lone Echo mechanic, and we kind of wanted to, I gave you a challenge on how to do a flight mechanic, but what happens when both triggers in the motion controllers are pressed. So what do you do then? Yep, so to kind of do the, which is going to be a bit difficult now to kind of test, but I can show you the general flow of what needs to be done. So I can do, maybe let's do Notepad. So we're going to do a modification of the answer to on your own challenge last live stream. So we're going to do a modification of the flight mechanic where you have two motion controller triggers pressed, right? So think of it as your motion controllers having like thrusters underneath them at the bottom, sorry, a la Lone Echo. So, and that's kind of like the mechanic that we want, something like Superman, where you have two motion controllers, and then you want to kind of get a nice rotation or a nice direction, depending on where the two motion controllers are facing. So the first, so one of the our viewers last week felt that it was complex. So normally when you feel this way, try to break it down to simpler steps. So for me, I would break it down like this. So problem one would be, how do I know if I have the two triggers pressed? Right. So, and then problem two is, how do I calculate the correct rotation? Right. So this one from a last live stream would be relatively, you could intuitively kind of understand what you need to do. So you can either do similar to our B is moving, right? Boolean. You can do two booleans, which checks for motion controller left and motion controller right triggers, right? And then you need to keep track of these two booleans to make sure that they are set. So that's a bit finicky, but it is a solution. And in saying this, when I'm do the solutions, keep in mind that there's this is not like the only solution. You probably will come up with other solutions, probably even better than what I've come up here. But this is my solution and how I would solve this problem. So either with two booleans left and right, which should work. But I feel it's a little bit too clunky because then I need to keep track of these two booleans all throughout, right? So what would be a good solution for that? So we can go to let's look at the Vive motion controller input and look at some images for UE4. So something like this, right? So if you look at this, there's something called trigger axis. So it gets measured every frame, so from 0 to 0.95. So it's always available, this trigger axis, a motion controller trigger axis. And it clicks from 0.95 to 1, so we know that it's triggered. Or, you know, when you're pressing the trigger, it kind of tells you like how far along the trigger has been pressed. So that's what the trigger axis is. So a good solution could be is that when we do the check, instead of the two booleans left and right, we're gonna do a check on the trigger axis. So we can do a trigger axis left and right, and they could be greater than 0.95, or just to be safe, you can do a greater than 0.8. So if it's 80% pressed, then you can consider that as pressed. Okay, so that is a solution that we can do, and just not sure what's going on with Unreal. So it's taking quite a bit of time. All right, so that's gonna be the solution for that, at least from my end. You can of course do this one, right? Or solution 2. There. Okay, so just gonna quickly look at the Twitch to see if we have any questions. So we don't have any questions, so I'm gonna leave it there. Sorry. Okay, so problem 2. We have, how do I calculate the correct rotation? So you just have to, this, you can either do a median of the rotation, right? So you want to get the, like the midpoint of two rotations, which could come up with like really complex calculations. So you could also think of it intuitively, like left rotation and right rotation. Right, so if you have got the left and the right rotation, and then basically you want to get the delta of this, meaning the difference between the left and right rotation. And with that difference, we can add either the left or the right. So I guess makes sense to do the left rotation plus the left rotation, right rotation, and then you divide by 2. So you get like a halfway point or a midway point. So you could do that. So that should be an equation that should work. And this equation, I've tried it. It works really nicely when you do this kind of calculations. For those physics buffs, it might be too simplistic an approach, or not completely accurate. But you have to think about the medium that we are building this on. So the medium is VR, and we want to see how the effect of it is in VR. Like how does the player feel when you're doing the this kind of mechanic and this kind of rotation? Does it feel real? Does it feel like it's intuitive? So when I tested this on my VR rig, it does work relatively well. Especially if you imagine that you've got the thrusters coming out of the bottom, so to kind of explain this kind of movement mechanic or this flight mechanic. All right, Unreal, come on. So we got 52%, and yep. So we'll just have to kind of have a look at that. So while we're waiting for that, I'm gonna go to the next one, which is the gaze mechanic. Right, so for those wondering why I'm typing this all in Notepad, and just coming into the stream, I've got my VR rig crash on me, so I'm doing this on a non-VR rig, but so on a personal laptop, and I'm doing and all my slides I have to basically redo now from memory. So we've got the gaze mechanic. Yep. So what's the main objective of the gaze mechanic? First, you'll have a point A, right, which would be the camera or the headset location. And you need to be able to do kind of like a line trace or laser beam coming from the camera onto point B, which is our target, which would be an object that we want to test. So we're going to be doing a line trace, and we're going to be doing a test on that on a hit for the line trace. So what do we do with that test? Do we check what type of object it is? So we can do that, similar to what my plugin does. And so does it have a tag? So my plugin does this as well. So, and currently on this, as of this recording, my plugin doesn't do this, but it's easily implementable in Blueprint, and we're gonna do both in Blueprint and C++. You can check if it has an let's keep that word there for a while. So we does it have a function that we want to run, for example. So we're gonna look at these 3 types of ways of checking hit from this line trace. All right, so that's fine. So we're gonna rebuild the shaders on this machine, but we're gonna look at the code now. So I'm gonna open up VRPon. All right, so we left off with flight movement in the C++ side, and then flight movement on the blueprint side, and the flight movement on here, right? So on, sorry, blueprint and C++. So I'm just gonna remove all that so that we don't run it. I don't want the 360 to be running for this. And we're just going to focus on the flight movement. All right, so let's start with giving ourselves a little bit of space for this mechanic. Might be a little bit messy, so all right, so we're gonna check if we're moving. Actually, this is for the gaze, and we'll think about this. All right, so this is when we're moving, and let's have a look at this. So we have the problem one is, how do I know if I have the two triggers pressed, right? So we're looking at using two booleans, then we're gonna have to kind of keep track of two booleans all throughout. So whenever the trigger is pressed or released, we need to keep track of it, so it could get a bit clunky. So another solution is to get a look at the axis. So how do you do that in Unreal? So you just right click, so then you try to get axis, and motion controller, axis, trigger axis. So we've got the left and right here. So we got left, sorry, that's the event. So let me just show you, I can type that in. So you've got events and values, right? So what we want, we don't need the event or when this is triggered. We just need to know what the values are at that given point in time. So we can use the gamepad values, motion controller left, trigger axis, right? So that's the first one. And then we do the same thing, right, trigger axis, and then make sure that we're doing the values instead of the event. Okay. So then what did we say? We have to check if it's greater than a certain value, right? So we do greater than. And we check if it's greater than 0.8. We've decided earlier, so 0.8. So if you're following along and you've got your VR gear, so you can easily test this. So I'm gonna do an n boolean, so we're gonna add them both, do an n equation here, and if they're both true, then this would be true. So then we do a branch. Alright, so this now is our simple test. Test if both triggers are pressed. Right. Then we just basically replug them in. And then if both triggers are pressed, we do something. If not, we do this. We do what we used to do, which is just move based on the movement reference. Okay, so now we get to the second part of this issue. So the next problem that we have, if we go back, is to how do I calculate the correct rotation? So basically what we're looking for is a median rotation. So the rotation of left, and then rotation of right, and then find something here in the middle here for these two rotations. So it's called a median rotation. There's some complex calculations involved, but for what we need for this solution, for this VR solution, we need a very simple solution for it. So we can first get the delta of the left and right rotation. So let's do that. So we need to get motion controller left and motion controller right. So left and right, and then I'm gonna do get world rotation, and I'm gonna do get world rotation here. So I've got get world rotation, and we need to get a delta. So let's do delta rotator and this. Alright, so now we've got a delta rotator and we want to divide that by 2. So the way we can do that is we split this and then divide each of the axes into by 2. So we do this, do a divide by 2. So I'm just gonna control W so I can do a, sorry, can duplicate that and that. Alright. Alright, so while I'm doing this, I'm just thinking maybe I'll do a rebroadcast of this and just go over it again on when I have my VR rig up and running, maybe on the next live stream. But if you still want to follow along and just look at the solution, you can do so here, or maybe at an earlier date, but let's see. So I'm gonna do a divide by 2, divide by 2. So now we have this rotation here that we were looking at. So we've done this, and then we decided to use the left motion controller rotation and we add that in there. So we can use the same one here. I'm just gonna push it out here so it kind of looks a lot nicer. Oh, actually, I'm not gonna do that. I'm just gonna do this. Alright, so we can do something called combined rotators. The problem with combined rotators, it does a quaternion. Don't know how to pronounce that. Quaternion. Yeah. So if you, it gives you those values, and they could be quite inaccurate when you're moving. If we then simply apply it to the actor. So to do something to kind of force Unreal to do it from Euclidean type of rotation addition, we just do a simple addition on the rotators. So to do that, we're not going to use this simply because the values would be off, and when you do it in VR, you'll notice that on certain axes you're moving in the wrong direction. So we do a simple Euclidean addition of the rotators. I'm gonna break this rotator because I want to have all of the axes, right? And then we can, because we can reuse this move pawn from the C++ side, right? So we want this forward rotation changed. So I'm just gonna split that struct. And then, but first we need to do the addition. So I'm gonna do roll plus roll here. Right? So that. And then pitch plus pitch here. Sorry. Pitch. Let's pitch here. And then the yaw plus the yaw. And then we basically just plug them in to that one. So roll, pitch, and yaw. Alright, so it's going to be a challenge to kind of untangle this. Right, so we're going to do... Alright, so I made a mistake there. So this should go to here. This should go to here. And the result of this should go to there. Alright, so you have... Yeah, that looks a lot better. Okay. So looking back at our equation here, So from left to right, right? So we've got the left rotation, and then we get the delta of this, and then we divide it by 2, and then we added both of them to be the move pawn rotation. So that will be, if you try this out in VR, fortunately I can't because of this rig is a backup rig, you should be able to have a nice Superman movement. So press both buttons and then just try to fly around, and then see what happens if you spread your arms out. So you should be moving backwards, so it kind of feels really nice when I tested this earlier. So you're gonna do move when both triggers are pressed. So that will be my solution for this, and works. I think it works really well in VR. Obviously, it's not the be-all, end-all of the solutions. So if you have any other solutions, feel free to post them and then share it to others. So and then we can start a discussion. So it'll be really good to see what you got, folks have thought of. All right. Okay, so that should be the first bit of this stream. Just gonna have a quick look if you have any questions. So no questions. Probably good that not a lot is viewing this, but it will be on the recording. So for those just tuning in, I had some issues with my VR rig, and I'm using a backup rig at the moment. And yeah, so we're gonna do I may do a restream of this, a live restream of this episode, so that I can do an update here. So that might come in sometime this week or on the next stream. All right. So yeah, we've gone through upgrading the UE project. We've gone through showing you a possible solution for the one solution to do the on your own challenge from last week, where we did the modification of the flight and where you have the 2 motion controllers trigger pressed. So the next one is the gaze mechanic. So let me just go over it again. So you have point A where the camera is to point B where the object is, where you're gonna do the trace at, and you want to do a line trace from there, and then we're gonna do a test on a hit. So what type of object? Well, do we do a tag check, or does it have a function that we want to run? So those are things that we can look for, and we're gonna look for all 3 in this live stream. All right. So let's do the gaze mechanic. So we'd want to do a line trace, possibly every tick, which would not be very efficient if we always do it every tick, depending on your experience. So it's always nice to do a variable, something like is gazing, right? So if we're gazing, then that's the only time it will run that bit of code. So I'm gonna compile the blueprint and then set is gazing. So normally I start with I think about the states, like what variables I need before actually starting the code. All right, so I need the gazing. Sometimes it's difficult to think about it that way. You have to code a little bit and then move things out to variables, and that's fine. So but for this it's quite relatively simple. So I'm thinking is gazing, and then we need to know if we've hit something, right? So has hit. So we might as well do that variable there, and then maybe let's call it has gaze hit. And then I'm gonna do another one, which is similar to is moving. We need to kind of know how far we're gonna be gazing. So I'm gonna do gaze distance. And then change that to a float. And we should get maybe around 150 centimeters, and then that should be alright. So we should have is gazing, has gaze hit, and gaze distance. So alright, so let's do this. So we've got is gazing, and if it's true, right, so if it's true, then we do the gaze. Otherwise, we just simply go here. We could also move this out into a function just to make it a little bit more compact. But for this stream, we're just gonna do it like this. So, all right. So if it's true, we have space up here, so we'll use that. All right. So what do? We need to do the same equation. So if you remember it, we need to get the start location, and then we need to get the end location, and then use the distance so we can get the correct values for the line trace, right? So let's do that. We'll need the camera as a start location. So that will be, and then we'll calculate the end location based on the gaze distance that we have here. And let's see, the default value is 150, so that's fine. Right, so let's get the start location. So we do the get world location, right? And then we would add something to it. We would add the distance. So to get the distance from our last live stream, you might remember get world rotation, and then you do a forward vector just to get the forward vector of it, right? And then we multiply that by vector times float, and then we multiply that by the gaze distance. All right, so we've got those up and running, and then we add that. So this is our start location, and this is our end location. Okay, so let me just do this. The end gaze location. All right, so we're getting there, and now we need to do a line trace. So line traces are, I'll show you the line trace, I guess, so we can immediately see. Basically, if you don't know, you just do a line trace like this, and then you have like several stuff coming up here. So we're gonna do, there's several types that you could use. You could do channel. So basically depending on the trace channel that you want. So we've got visibility here. And in C++, we have a couple more options, and which I'm going to show you in a while. And of course, there are other types of line traces, which you can create a custom trace channel. So, for example, in your settings, project settings, you should be able to do a channel search. Somewhere here. So you could do an custom object channel or custom trace channel. So you have, and then you can set those collision channels onto your object and the scene, and then you can, then you would only get a hit if you hit those custom trace or custom collision channels. So that's an option. And also you've got profiles. Or specific objects. For our need, I kind of like using this one, simply because, especially in the C++, and I've got a lot more control. All right, so but feel free to play with the other nodes as well, obviously. All right, so we've got that. We'll just move this a bit up, and let's do this. So I'll do an add reroute node, just so that it's ready when we need to plug in, right? So, because these are just mainly calculations. And I'm running out of space already, so I'm just going to move this out. So it's probably better to move it into a function so it's not too crowded out in here. Alright, so we've got the line trace by channel. We've got the start location here, right? And we've got the end location here. So then we just plug this in. And then we can do a debug from here. But the problem in VR, this is not really a good solution, because it will come up like really thin, the line, and it will come up. I wish I could show you if I had the VR gear now. Then it would also make you cross-eyed because it's coming from directly from the camera. So, and I'll show you what to do instead. But that would be the basic code to do a line trace, and then if it hits something that's visible, then on the out hit, you could basically then check the actor. You could get a return value whether there's something that was hit, or you could just simply, which I like doing, is just simply check the out hit actor and then test if it's valid or not. Because if I'm going to use the out hit actor, a function from it, or to do a test on it, I'm going to look at it anyways, right? So what I normally do is kind of just do an is valid. So then I only need to test that without testing this. Probably a little bit, branch. So do a branch, do that, and do that. And yep, so then we know that something valid has been hit. So this is the basic code for it. If I now run this, this is not very VR friendly, and I'll show you how to make it VR friendly. Alright, so I'm gonna have to think how we're gonna manage this. Alright, so my motion controller is look like that now. Alright, so it's not even, yeah, the problem is it's not gonna be triggered. No, it's actually should be triggered. Is gazing, and then the draw debug type, let's do a persistent one. Might not look quite right. Yeah, it's not looking quite right on this here, so we can do an eject and then see how it looks like, that line trace. Not even sure why. Okay, so let me see. This is the problem when we don't have a VR gear to test on. Where is my pawn? There. Oops. Okay, so I'm gonna move my pawn a little bit so I can see stuff. So this was set up for VR, and I'm gonna have to do that. Alright, so we have that. Okay, let's try that again. So Shift F1, eject, and then we could see where the line trace is. So then we just move along, and then you could see that we have the line trace there. Somewhat off with this debug line. So now we need to, and that's why I don't like using this one, especially in VR. So we can do our own custom. So the line trace should come from within the camera, so that's fine. But we need to do a debug line. So you can do draw debug line. So there's a node for that. Draw debug line, then draw debug line. So we can use this one, right? So the line start, and this one for the line end. which is fine, except if you think about it, for VR, let me just pull this down just to make it look a lot more readable in the long run. Okay, so now the line end should be fine. The problem is with the line start. So if you think about it in VR, if we do this from the line start, then what will happen is you'll get cross-eyed because it'll come out right in the middle of the camera. So we don't want that to happen when you have your headset on. So we're gonna add a vector to it and then add a Z value. So I normally add like 25 in there. So it's kind of like a magic number. Normally you don't want any magic numbers, so you can specify a variable and then you can just modify that distance there. So let's do that. Let's do a vector here. Anything that you have more, if you have a variable that's more than 1, it's usually called a magic number in programming, and you try to stay away from that and do a variable for it. Okay, so we do a HMD offset, for example, we call it, and then this time we can do a default value, which can have that magic number. Then we do this. All right, so now we have an HMD offset. So that will be for the line start. And there you go. So now we should have a debug line. Let's make it red. Something like that. And let's make it again another variable. Let's do debug line thickness. And we can make it a float. Let's make it 25. Obviously I could have just put it in there, but we might as well do it properly. So okay, so at the moment we're just doing a draw debug line each and every time. Let's just test this quickly first. Alright, so now you can see it looks a lot better. So it's coming from on top of the camera onto the scene and hitting something on the scene. So let's give it something to hit. And I'm gonna do that. Let's do something like maybe a cube out here. And let me just look where we can. So just make it a lot easier, because now I'm not unable to move in VR. Well, I can, but I need to set up the inputs and we don't really need it at this point. So we'll just have to make sure that it's, at least for the core mechanics that we're doing, it shouldn't be too much of a problem. So let's do it from the top perspective, just to make sure I'm doing the alignment right. And let's have something like that, and then maybe left. Yeah, just to make sure we're going to hit it. Yep, so something like that, I guess. Go back to the perspective. Okay, and yeah, so looks like it's hitting it. And to quickly test that, we just do let's just do a print string and do this. Obviously after all this you still need to put it back here, but we will not focus on the movement anymore from here. We'll just focus on the gaze mechanic. So you could see hello, 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 hello. Let's not make that hello, 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 hello. Let's have it show us what we've just hit, right? So just drag that in there. This, Okay, so then you could see cube, 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 cube. All right, cool. So we've got the gaze mechanic running now. Okay, so another thing that we have, I think, missed here is that obviously you don't want that draw debug line each and every time. So maybe we just reuse this should draw debug, right? So, and then we'll just set it to true by default, like this. Branch. So if it's true, then we draw the debug line. If it's false, we go directly to the line trace. There, so now you have a way to kind of turn on and off the gazing and turn on and off the debug line. So which could be useful for your experience. But by default, we'll have those debug lines for this experience. All right, so now that that's running, we basically have the base mechanic running. So if you go up here, we've basically done this, so the line trace. So that's relatively simple mechanic. So it's just a matter of doing the same vector calculations we've done before, but we added a headset HMD offset for the draw debug line, so we could kind of have a look. So another thing that you might be interested in doing is to, of course, have a look at the what kind of object it is. So if, for example, we can cast it to a cube, should have the cube there somewhere. Did we have no? Okay, so we could create a blueprint out of this. So I can create a blueprint out of this and then just call it, yeah. Let's leave it as that for now. So cube blueprint. So you could do a simple cast to cube blueprint, right? And then if it's true, if it's cube blueprint, then you do a print string. So that is a simple way of doing that. Or you could do a tag, like check for an actor tag. Like if I click here, you can tag every object that can be gazed at. So if you click on that and then press type tag, then you can have here, or by default, it's actually better here, so that it's available on all kinds of the cube blueprint. I could do a tag, and then I could do reacts to gaze, for example, right? All right, so then from here, what you can do is to do a simple hashtag, actor hashtag reacts to gaze. And then, sorry. And then if it's true, then you do the action that you want. So that's two ways of doing it. And the third one would be what I mentioned. Does it have a function that we want to run? So how about if there are different actors, different kinds of actors, but we're looking at something that it can do? So that's where interfaces come in. So I'll need to introduce interfaces in a bit, just so that you have a basic grounding of what an interface is before we proceed. All right. So that's the gist of this basic thing, and I'm just thinking if we do the float now, but let's keep it as it is for now, like this. All right, so let's look at interfaces. So what are interfaces? What are interfaces? So think about it as a, let me just zoom this in. Okay, I'm using Notepad. All right, so what are interfaces? Think about it this way. What do Charles Xavier, Storm, and Magneto have in common? Right? So if you think about it, they're all mutants or X-Men. If you're familiar with the series or the comics as well, so they're all mutants and they're all X-Men, right? And what else do they have in? What do mutants and X-Men have in common? So they basically all have abilities with them. So all mutants and X-Men, what differentiates them from a non-mutant is the ability. So I'm just oversimplifying it, obviously, but so what basically differentiates them from the race, from the rest of the human race? They basically have certain abilities with them. So, for example, Charles Xavier has telepathy, right? And Storm has, what does Storm have? Weather control, which is pretty cool. And Magneto can affect magnetic fields. Right, so that's their abilities. Just gonna do that so it's a little bit easier to see, since I have none of my slides available because of my rig getting nuked on me last minute. So anyways, I need to probably restore the system from backup, but alright, so what we have here is mutants, X-Men, and then we have Charles Xavier, telepathy, we've got Storm, and we've got Magneto, can affect magnetic fields, right? So that's their abilities. So you could think of an interface, so the ability as an interface in this analogy here that we have. So mutants as an object or as an actor in your scene have interfaces. So like mutants or objects or actors in your UE scene can have an interface. But what's an interface? An interface is simply just a definition of something, right? Definition of a function, actually, as we call. So definition of something that can be done. So, and it doesn't have anything else other than a definition. So it just tells you what it is. So it could be something like doability, for example. So in this case, so that's an interface, and this specific implementations of the ability, so maybe I should put that at the bottom, not destroyer. So the implementation of the ability, such as telepathy, weather control, can affect magnetic fields, happens on the object, on the actual object. So your object actor could be something like a template, and then it has an interface, or you could think of it as a separate thing, like an interface is the ability, and then you add this interface on the specific objects, and you would have there, you can specify what the actual thing does. So you can just have doability, and here it's telepathy, weather control, and can affect magnetic fields. So an interface basically is something like this. So I'm oversimplifying it. There is obviously a better way of, for object-oriented programming, but to kind of simplify it in a way for what we need at the moment in here, just think of it that way if you're not used to object-oriented programming. Just think of an interface as something like an ability or a function, a definition of a function So basically it just says do something. And then when you implement that interface onto an object, there you specify what it actually does. So it could be anything, but it will have the same function. It is still an ability, but the actual ability is defined on the object that you're implementing the interface on. So that's kind of a little bit of a visual for you, although not, because my PowerPoint slide is not here, can't see it as a visual, but kind of like something to think about when you're thinking of interfaces. So in the way that UE4 and blueprints are done, it's commonly used as a communication between blueprints, but the actual technical thing that you need to think about is this, which it helps to know the actual technical bit, simply because when you're trying to implement it, you know exactly what it was meant for, and then you can use that in the C++ end as well, relatively properly as well. Okay, so that's what we're gonna do. So that's what an interface is. I don't know if there are any questions, but none. So I'm gonna just move on ahead. All right. So with that bit of knowledge of what an interface is, let's just actually create one. So I'm gonna create a blueprint. So it should be, an interface. So let's call it BP interface. Right. So I'm gonna go to the cube blueprint, and then now I'm gonna implement this interface. So if you remember how it's done here, I've now got an interface, which I haven't done much, so we should actually do something with it. So we have a function here. We'll call it respond to gaze, right? We'll call it respond to gaze for this. So we basically now have an interface called BP interface and has a function called respond to gaze, but nothing defined in here. So see, you can't define anything. It's just a definition. So as we could see here, so it's just a definition of something or a function that something has to do if you add this interface onto it. So with a cube blueprint, if we're gonna add an interface to this, we're gonna have to then define what that interface does. And you go to class settings to do that in blueprints. You do add, and then you do let's do BP interface, right? And that's it. So you should have BP interface already added into here, but we don't have an implementation. Let me just clear it up. So as you could see from the graphic that we have here, so they need to have an implementation. Or this is where you can specify. In blueprints, it actually allows you to do that. If you're doing strict C++ coding or strict object-oriented programming, anything that inherits from an interface should have an implementation. But I believe in blueprints, it's a little bit loosey-goosey. You can add, don't need to technically add one for it to work, and it will still not give you an error, which is sometimes good, sometimes not really good. It allows you to do too many things that could get you in trouble in the long run, but that's how it is. So we're gonna do a what did we say it does? Do something, or no, respond to gaze. So respond to gaze, right? Okay, sorry. We don't want to call it. We want to define it. So we create an event, respond to gaze, and then we do responding from an interface. Yay. Alright, so now if we run our code, it should both print the cube and I'm responding to gaze. And it doesn't. So cube blueprint, and let's see what happened. Alright. So, and I think I know exactly what happened, but alright, so we've done this. right? So I'm just gonna leave that, other options. And we're gonna focus on the interface. It's a little bit more complex, but a lot more powerful. So it does this print string. Let's keep it there. That's fine. But then we need to check if it implements an interface. Right? So if this actor is valid and it implements an interface, and what's the interface? BP interface. Do a branch. If it implements an interface, that's the only time it does that. Now let's do this first. So you could see that the cube blueprint does have an interface because it's going through this route here. So what can we do then? So we can then check, we can then do the respond to gaze like this. So just drag it, click it, and then call the respond to gaze of that object. So once we've checked if it implements an interface, then we can do that, and then it can respond to gaze. And then put this down so that it's a little bit more readable. So we could, I guess, do this, that, and then move this. And then do that. All right, so if we do that, now we have something that says, I'm responding from an interface, yay. So you could see from there. And that's how to do interfaces. And for me, most important thing is to understand what it is and the power that it can do. All right, so that's on the blueprint end. So that was kind of like a whirlwind tour through it. Although technically we've gone through an hour already. And as I promised, we're gonna look at the C++ version of this, of how we're gonna do the implementation. So let me just get my bearings back. So we're gonna do the gaze mechanic. And I think on the last stream we did a blueprint function library simply because I kind of wanted to introduce the function libraries as well. So, but for this one, let's do a completely C++ solution from a component, right? So if you go from VR pawn, we can then add a component. So I'll be doing this similar to how I normally do my coding for my plugin. So I'm just going to do file new, new C++ class, and then we'll use, so you can use an actor component. The thing is with actor components, you can't attach it to scene components. So, and this component, we need to attach it to the camera, or I want to attach it to the camera anyways. And yep, so I'll do the scene component, and then we'll call it VR gaze component, right? And then create class. And that's how you create a component in C++. I will update the README on the GitHub repo in case people come back to this afterwards and try to look for the code. I'm not gonna be updating it because I've got 4.18.0 here. Sorry, 4.18 preview, and I want to do it properly on the 4.18 release. All right, and obviously to be able to test the code properly on the VR gear. All right, so that's loading. And we should have VR gaze component in here. Let's open up the header and the CPP file. All right, so from the header, let's do some of the variables. So similar to what we've done in the blueprint side, if you remember the process, so I've added this variables here. So I'm just gonna be doing pretty much the same thing. I'm gonna do a U property okay. So we're gonna do a blueprint read write. I guess category VR, something like that. All right, so I don't have my visual assist stuff, so normally I put this on my visual assist so that I have it, I don't have to type it all in and I don't have to remember stuff. But yeah, so now this would be a test to actually remember them still. All right, so U property, we need a boolean. Right, so B is, so I'm adding a B in there because that's the convention for UE4 C++. So it gets removed once it's shown in the blueprint side of things. So, and then we want it to be set by default to true, so we do that. And now I can just do copy paste, and if that was right, but that should be right. So we need is gazing, and then we had another boolean, show debug, right? So, and show debug, we want it to be also true, and we want a float value, which is the distance, the gaze distance, and gaze distance is equal to 150 float. So, and then we do a vector. Simply because we've done the blueprint, it's now easy to remember what it is. F vector is equal to HMD offset. Yes, and then F vector. Oh, sorry. I normally do something like this, 0 vector, but anyways, it's always 0 vector, but we're gonna do F vector in the X, Y, and Z, so nothing on the X. On the Y, I want 0 as well, but on the Z, I want an offset of 25. This is for the debug line. And that's pretty much it for the variables that we need here, right? Okay, so, and then the next bit is we want this to happen on every frame, and which is what's nice with component as well. So if you go back to Unreal, if it allows me to go back to Unreal, which it doesn't seem to be wanting to. And why do I have 2 of these? Oh yeah, so because when I created one, Unreal opened another one. So where is my Unreal? Let's close that and reopen it. Alright, so, and then we're just gonna, should have compiled first, but we should just compile. Okay, and then we're gonna compile. Okay, let's have a look at the coding. So we've done no code at the moment. And we're just basically gonna do a debug and a line trace. All right, so C++ compile complete. Go back to the content. We open up the pawn. That in there. Okay, so what do we have? Then I want to do something that I'll attach that component to the camera. The reason for that is that so that whenever the camera moves, the component moves with it, and we can then when we get to this point where we're checking for the camera, I don't need to check for a camera. I just need to get the location of the component itself because it's anyways attached to the camera, right? So that saves us quite a bit. So we do a gaze component, right? So it comes up here as VR gaze. So there you go. So now you have that, and then if you look at the VR, we should have the variables here, but it doesn't seem to be giving us any of the variables. So let's go back to it's set to public. Need to set the edit anywhere. Okay, so I think it's called edit anywhere, but for now. We could also kind of peek at what we've done last time. I know we haven't done view properties for this code base before. Should have, there you go. So I forgot the edit anywhere parameter. So you got is gazing, show debug, gaze distance, and an HMT offset that you can tweak. All right. So since this happens every tick, we basically want to disable the blueprint version here. All right. So let's do this. Sorry, wrong thing. Because now we have our own on-tick event that happens here on the C++ side. So I'm just going to disable all of that. We've done from the blueprint side. Okay, so and let's create the same functionality. So you can remove certain functions like this by just simply removing begin play. I don't think we need begin play, so it's really good to clean up a little bit. And then you can remove this, but we will need a tick. So on the constructor, you need to set that true, and then here. So and then we do a gaze mechanic here on event tick. All right. So what do we need for the gaze mechanic? We'll need to do a draw a debug line, right? And we'll also need to do a line trace. Okay, and then we need to think about do something if something is hit, right? So that's the 3 basic steps, and I'm just gonna surround that with if, I guess. Yep. All right, so if, what was it, B is gazing, right? If B is gazing, we're gonna do that. And then the debug line, we do have a check if B draw debug. I think I called it draw debug, right? Nope. What did I call it? Show debug. So B show debug. Oops. B show debug. Alrighty, so we got B is gazing, B show debug, and then we do a debug line. So we could use the engine one. There is one for the Kismet library as well. So maybe let's have a look. So the G engine is undefined. We can do include engine / engine.h. Okay. It should bring the engine with us. Alright. Visual Studio, yep. So and then you should have draw debug. I think this is an add-on screen debug message that we want to do at the end. Alright, so where is our debug? I think the debug line is in the world. So we do a get world, sorry. And then debug, draw debug. Can't seem to find that. So, and this is good, this is okay. Then I can show you how, if you've forgotten. But I'm pretty sure it was one of those. Let's look at the API, UE4 API. And, right, so. I think there's one in the system. There's two versions. One I'm pretty sure was on the engine. I think my Visual Studio is not. Yeah, so it's in the Kismet system library. So for things like this, you could just simply do this. So Kismet system library. I'm pretty sure it's under Kismet. Let's compile this and see what it does. Because my Visual Assist here is not working as it should. I'm pretty sure it was a G engine. But yep, so we have, yep, so Kismet system library, and then, yeah, I guess this is actually even better, so we can do that. Then you can, let's try. Thing. Okay, so we can do then Kismet system library, draw debug line. You could use all those as well. This is like it has quite a bit of stuff in it. So you can have draw debug line, draw debug plane. So it has a lot more functions. And there's one in the engine that I do use just for quick ones, but I guess this is better. So we need a world context object. So the world context object is just to tell the engine which level or which world it should be rendering on. So we just do a get world, and then what was the next one? Will be the start location. which would be this get component location, right? And that should be the start point. And we add the HMD offset. And then the endpoint is the get component location plus we get the forward vector the get component component rotation, not the location. Then we do a vector. Oh, there should be a dot vector. This, oh, need the function get component dot vector. Then once we get the effort data, we can do a dot vector on it, and then we multiply this with the case distance, and that's it. And that basically does this part here, which is similar to what we've done in the last episode. Sorry, here. All right. So if we go back to the C++ end, what else do we need? We need a line color, so we can do f color. Let's make it red, so 255, 0, 0. Make them floats. Clear, they are floats, and we need the duration. No, maybe let's do 1 second, and the float thickness is, I think I made a variable for it in Blueprint, but not here. But I'm just gonna hard code that in there, 15f, and then that should be it. And we've got ourselves a debug line. So if we compile and run this, we should have, because right now without compiling you could see it does nothing, right? Because we've deactivated the Blueprint version of the gaze mechanic. So now in the C++ where we made a component, and we're doing basically at the moment just a debug line. So we do an iteration just to check if we're doing the line trace correctly. Right, so this is going a little bit better than I thought, although of course it would have been better to be able to demo it on VR. But at least all of the basic mechanics, all of the basic code, and the core pieces of code that we need are basically can be easily tested from the editor. But do test it obviously in VR for the full effect. Okay, so that's compiling. See if we've got any questions this time around. No questions about oh, I haven't signed into YouTube, so might have some questions in YouTube. My live everywhere. Yep. So it's oh, we got a compile failed. Let's have a look at what that. Oh, it's gonna open another one. Let's close this. Shouldn't have clicked on that, but okay. Alright, so what does it say? Line 32. This one. I thought it was get component rotation. Let's see what the vector is. So the vector is a method, so I need to change that. Because of the lack of consistency, you know, it would be nice to make it like get vector or something, or make vector. Sometimes it's a bit confusing. Where was I? do build. Should be the hot reload there. That's the profile that I have. Okay. All right, so this is our thing. Okay, so now I'm not sure if we've done the. I guess I've closed it so the hot reload is wrong. Right, sorry, I'm just gonna have to recompile from here instead of waiting for that to come up. Shouldn't have closed it, but here you go. So I've got a compile complete, or there's something wrong with the code itself, actually. That could be the cause. Alright, so I'm not seeing a debug line, but maybe it is showing a debug line. I'm just not seeing it. Well, it should be almost the same, but let's see what happened to our code. Okay. Show debug. True, true. Okay, so code seems okay. The component location plus the HMD offset. Let's do a show engine, show on screen debug. Add on screen debug message. Key, oh, key none. I think there was no. All right, let's put it to 0. Float time to display, maybe 1 second. It runs every frame, so it's fine. F color. Let's make it green. And then, oh sorry, it's an integer. Mistake. That might be what's causing that as well. And also we need the debug message is an F string. Okay, I think that's pretty much what we need. So we do build. I just kind of want to see it on screen. Compile and try that out and see. Alright, so I guess just a compilation issue, but it looks like it's correct. So we're doing the line trace and we're doing the gazing. Alright, so that's fine. We can reuse that and say And then we can do something with that in a while. Okay, so if we do that, I'm just thinking we need a line. So we've done this. Now we need to do the actual line trace itself. And to do the line trace, we're gonna use line trace by channel. Just trying to remember. I'll show you first. I guess I can go about it the way I would normally go about it. So get world should be able to do a line trace here, single by channel. Should be pretty similar to the one we've done in Blueprint. Obviously I could also use the Blueprint version, but I'll use this one. I'll do a line trace by single. As you could see, it returns a boolean, right? So I want to catch the boolean, which is basically what you've got here. I think it's even the same one as the Blueprint version. So line trace by channel, so that's the boolean there. On the C++ version, I kind of want to get that, I guess. So the hit equals to get world line trace single by channel, and you could see that we need an out variable here, an f hit result. So I need to define that. Okay, so call it out hit, I guess, and that's it. Not define anything in there. And then we do out hit in here. What else do we need? All right, so we need the start and end vectors. Then it's just a matter of copying and pasting this from their debug line, right? So now that we know that it works, we need a collision channel, collision channel. So should have a bit more. So you see, you could have a little bit more here, and then you can have the custom ones as well, which I showed you earlier in the stream how to set. So I'm gonna do the same one for visibility, same ones we have in the Blueprint side, and I guess that's at the minimum that we need. So we'll keep it to a minimum. All right, so that's our line trace from scratch, and you could always add this onto your Visual Assist stuff, or your code snippets in Visual Studio, so you don't have to kind of remember them, similar to the stuff here. But once you do it quite a couple of times, you basically get an idea, like in your head, of how it is, and you could formulate it from here or from the API. You could just simply find the line trace, for example, like this, and it should be available here. So I guess this is a documentation. Normally I like to look at the API, but I guess for the API you need to have the exact functions, but you can always check as well as the documentation, right? So that's fine. So if you do, and you could do, oh, this is blueprints, so you could do something like this. And then you could have some things from the answer hub if you want to. But my style is normally like this. Line trace single. Normally you can find it just takes a while to get through it to find the correct one. But yeah, you could see it from here. And then there are other ones, obviously, like line. You can then search for this one. So that's one way of you can go around the spot, and then you could see all of the available ones, which is what we were doing. So anything with K2 normally means that it's the version that's opened up in Blueprint. So then you could see, you could also call them obviously from C++. Alright, so anyways, that's how to do it kind of manually. So I'm doing it manually here because I'm on my backup laptop. All right, so that's the line trace, and then we will only do I've got a hit if we have a B hit, like this. So I could also just ignore that and then just do an out hit, right? Similar to what we've done in the blueprint side, but I've already done it. So out hit, I think, no, it's a upper var. Cool. So get actor. So I guess this is a soft pointer. So get actor, and then this one is a pointer. It's valid low level. So we check if it's valid, and if it is, we get a hit. Let's do the same thing as what we've done in the blueprint side. Okay, so we need to convert this to a string. Problem with the on-screen debug message is, yes, so it's in const f string, so we need to do a formatting. I've hit %s, right? Then we need to do we need to use f string printf, and what we need to do is out hit that get actor, and what do you have for me? Name. Returns the name of this object without any path. Yeah. Get full name. I guess get name should be fine. We just need to know the name of it, right? So I guess it needs a pointer there, and there. That should be it. And then do that. So now it should work similar to the blueprint side. So last week was my microphone delaying me, and today it's the, oh, did I miss something? Okay, so problem is it needs to be a const. So I was thinking I could do a string here, do a formatting, or I guess this is, that was, I guess, my mistake there. That should turn const, then, yep, let's see. Otherwise we'll just return a float. The string handling gives me any issues. Looks like it's running. Yep. Okay, so yeah, I forgot it's a method. That's that. Well, it's get. So it's a getter. So we have. So now you can see I've hit cube underscore blueprint. So it's kind of like the one. I don't know if you could see that. But I'm gonna shift F1. You can see from here, I've hit cube blueprint, right? So, all right, so that's working. So we've done the foundation work. So it's kind of how you would want to do like coding. So similar to the one in blueprint, we're doing it per iteration just to check each step if we're doing things right. And so far we've been doing things right with a few bumps along the way, which is common. All right, so we've done a bit of debugging, draw debug line, draw the line trace. All right, so now a new concept, which would be a delegate. If you look at here on the the line trace to a single channel, I'm thinking, do we do a delegate or the interface? Actually, we can do the... Alright, so basically what we're doing now on this C++ side is simply just hitting something and then showing a message. So what happens if we need to expose something for Blueprint users so that they can hook up to that blueprint, to that event, and then be able to run their own logic? Because at the moment this is all done in C++, but as I mentioned, I advocate like a combination of Blueprint and C++ and for the best of both worlds. So a lot of the heavy lifting done in the C++ end, and then some stuff can be done on the Blueprint side for like really quick business logic and stuff that can change quite often and can be used by games designers or mostly like Blueprint users, more visual stuff, right? So we can do that, and I can show you how to do that. So I basically want to expose an event here. So I'm going to expose a delegate event. So a delegate, if you're used to C#, it's actually pretty sure it's a C# convention, C++1. So it's C#, so you get a delegate that kind of runs, it doesn't specify, kind of like the interface that I mentioned earlier. It doesn't specify what it does, but you know that you can call it, and when you call it during runtime, then you can, the definition can be set at a later time, or you could set the, it's basically a definition of something that you need to, that you can run, you can execute. So it's kind of like a guarantee that it will execute something at some point in time when it's called, right? So in a very, I'm trying to nail it down to a very basic statement, but I guess that will do. So just think of it as a, I guess, so for a visual for UE4, kind of think of it like an extra event in here that we're going to be exposing. So it's a lot more deep technical in terms of the C++, especially because it's not, pretty sure even in C++ 11 it's not native concept, but Unreal has implemented delegates for UE4. So, but if you're in C#, I guess you're already familiar with delegates. So it's pretty much a similar concept. All right, so let's create a delegate for this that we can call from within Blueprint. So basically we're creating an event here that Blueprint users can hook up to. Okay, so what do we need to do? We need to declare a delegate, need to do it from kind of memory. So declare, oh cool, we've got stuff here. So there it is, so we don't need to do it from memory. So you can declare delegate, declare underscore delegate 1 param, 9 params, 2 params, blah blah. That just tells you the number of parameters that you can have, that it could have as an output. So for this, let's just do, I guess, an F string, right? So, or we haven't done anything on the delta time. Yeah, so let's declare delegate. Actually, I want a, okay, so I guess that's still wrong because I want a dynamic delegate. This needs to be a dynamic delegate, and then it has to be a multicast delegate. So there's several of these options of these macros, and if you look at the documentation, should be available in there if you want to. and it kind of explains to you in detail what each does, right? And I'll leave it to you to kind of have a go over it. But at a very basic level, you can do a macro like this, a UE4 macro, declare dynamic multicast delegate, one param for a single parameter delegate. And trying to remember. So first we need the delegate signature. So we do an F, that's the convention. So F, what do we call this? On gaze hit, I guess, yeah. On gaze hit. So I think that's the same one I use for my plugin. And then the parameter, let's just do a boolean, something simple. Bool b has hit, right? So, and I think that's pretty much it. And sure if the macro requires the semicolon or not, but let's leave it there. So declare dynamic multicast delegate, pretty sure, yeah. So, and then that kind of declares a delegate for us. So now we need to create a property for it that we can assign from within Blueprint. So let me see, we can do uProperty. Don't know if it's gonna, and then it needs to be Blueprint assignable. So we can assign it from, actually it seems to have come up there. Blueprint assignable, no. Suggestions. Okay, blueprint assignable, and we can put a category, yes. Right, and then we use that name, F on gaze hit, F on gaze hit, I guess, and then we can call it on gaze hit. Oops. Once we compile, that should be available. And I think that should be it from the header side. So now we need to call that. So we need to, we'll leave this on-screen message here. And then on gaze it, sorry, broadcast, we need to do the parameter which is true. And then I guess, so if this is else, on gaze hit, that false. Actually that's wrong, don't need, because the boolean you don't actually need. This boolean is actually not quite right, but it's fine. I just want to kind of show you what was it. So yeah, we'll return true. Correct. So it will always be true because we're doing the test here, but just for testing. So we'll do that. We'll build. Okay. So you declare multicast here. You declare the number of parameters, and then you put the name and then the parameters. So parameter type and then the parameter name, and then kind of like this, right? And then you create a property that's blueprint assignable, and then put the name that you specified in there, and then type it here, and then from there do a broadcast. That's how you do dynamic multicast delegates from within C++. And the magic it does, I hope it works, it should work. Yep, you'll have this event then that gets triggered every time we actually hit something. So now we're not bound by this on event tick by here. So we now have our own event, which is a lot nicer, I would say. So I'll just work from here. So right, so then we can do, I guess, print string. You know what? Hello from Blueprint. So we can do that. Alright, so do that, and then replay. So we do a hello from blueprint in there, as you can see. It gets triggered. So this event gets triggered if we hit something. So that's how you use delegates. Let's make it proper. I want to return not just a hard-coded boolean like this. I want to return actually, I guess the whole hit results, right? So that the user can then make use of it. So I'm gonna do f hit result here, and then just call it out hit, and then from here we just do out hit. All right, and then it should have the whole hit result instead of just a boolean. So it's a bit finicky. It looks a bit finicky at the beginning, but once you get used to it, it really flows really well, and you kind of you kind of know where things are and have more control over things. So a lot more granular control, and it's really nice to be able to do like exposing stuff like this for Blueprint users. So now I'm gonna just have to refresh this node. Why is that a boolean still? Let me just have a look. Because I guess, did I not? Result? That should be right. That seems to be a bug in there. I guess because this is a preview. No? My code, is it? Okay, so maybe we need to do a recompile for changing a delegate, because that looks right to me. Right, so let's do a recompile from here. Otherwise we'll do a recompile from outside the editor. Still not. Something weird is going on. No, I can't get rid of that. Alright, so did I do a build? I thought I did a build. Let's do a rebuild, just to be sure. And then open it up. So unless I'm missing something simple. See, and we haven't gotten to the interfaces yet. I'm gonna have to quickly do it because I'm getting a bit hungry for lunch. Alright, so I have that, and we have this. Alrighty, so let's have VR pawn, put that in there, and VR gaze component, and gaze hit. There you go. So that looks much better. Alright, so then we have an on hit, then we can do a print string. Right, and then I guess we will use this one this time around. Hit location. So now we should have a location and as well as the name coming up, right? So there you go. So that's how you can do something like that. Expose an event from within C++, have the definition done by your Blueprint users, and yeah, and then kind of give them stuff that they need from here, like as an output. So that's what you can do with delegates. All right, so last thing is, I guess, the interfaces. So we've done an interface from within Blueprint. We're gonna do an interface from C++. So let's just quickly do this. So we've got, I'm gonna start with an empty class and CPP interface, I'm gonna call it. So obviously you would want a more better naming for that, depending on what it actually does for you. And this is kind of a bit tricky. And let's see if I can remember all the code. I've done it a couple of times, so it should be in my head somewhere, but let's see. Compiling new C++ code. Alright, so we may need to do a recompile after this, so I'm gonna close this up because it's an empty actor. And then I have to remove that crap there. Oops. And then reload everything. Let me just close this just to be sure. Close everything up. Right, so it's opening up the hot reload and I didn't want it because I need to do a recompile. So we'll do minute. So I'm creating a new custom class called, it should come up on the source here. What did I call it? CPP interface. So we got those there. Okay. So, all right. So as I mentioned, you don't really need the, for an interface, you don't need the implementation, but you kind of have to declare what you want to do. So let's see if I can remember most of the things to do this. We will need the generated files for this. But before I go there, let me just clean things up. Let's clean this up. What we need is an interface. So first thing is the macro U interface. Okay, so I was hoping that that would come up, but not. So blueprintable, we want a U interface that's blueprintable, and I kind of want a class. Then you define the class name, and then what is, I think it's Livestream. Oh, there it is. Actually, we use that. So Livestream API, and then what do we call this file? CPP interface. So just fit it to the naming convention. So U CPP interface, and then we'll it needs to inherit from U interface. I'm guessing, not guessing. It should be U interface. It's not coming up. So I guess when we recompile, it should come up properly. But it is U interface, if I can remember right. Yeah, U interface. So. But we need also the generated body. Generated body, but we need the, if you look at this, that should look familiar. This is the one that's automatically generated. Generated U, but since this is a U interface, it's body. Obviously, I could also just go to the API. But this should be, this I think is correct. So, and then, so once you have, well, basically we're just doing the class itself, but we need to actually do the interface. So we do Livestream API. Now let's copy and paste it, and then we need to do the I for interface, and then CPP interface. So that's the class, and then the holding, kind of like a dummy holding class, and then the interface is that. So think of it as X-Men, and this is ability, right? So if you remember the visual I provided earlier, that's one way of easily remembering it. And then we need to, that's gonna be the class. We need, I think, another generated here, because we have generated U interface body, so we need the generated I interface body as well. Okay, so that crashed on the machine. I'm paying for it now, having to do this manually, because I normally have this in my visual assist or my visual snippets, so it's less typing and less remembering. I guess that's pretty much it. But from the interface, we need to declare a function here. So I'm gonna declare a U function. Okay, again, have to kind of do it from scratch. So blueprint, we want, or actually this is a bit different because we want a blueprint native event, simply because I want this interface to be available as a native event in Blueprint, so the users can actually hook up to it, can use it, and then can redefine it from within Blueprint. Obviously, you can also do this from within C++, but for this stream, we'll keep it so that you do it from the Blueprint, because then I want to introduce a concept of like multiple inheritance, maybe on a succeeding stream, so that there's not too many concepts, because at the moment we're doing quite a number of concepts such as delegates, and then also this interfaces. So just to try to keep it simple, and then we can iterate over this, and then I can introduce multiple inheritance, which would lend well to defining implementation of interfaces from within C++. But for now, I'm going to expose it as a native event in Blueprint, so that Blueprint users can actually use those interfaces and define their own code. All right. So I've got the Blueprint native event, and of course it needs to be Blueprint callable. So you could understand now why I try to put this in visual code snippets of Visual Assist. Takes a bit of typing and takes a bit of memory work, because the standard code snippets don't have it. So U function, code VR, and then, so this is pretty much like old school how you normally do things. And then we declare the function. So I guess I'm just thinking of what to call it. We call it respond to gaze, yes, right? And although it's giving me a lot of those red lines, I'm pretty sure the code is right, or unless I mistyped it. And then from the C++ class, we should have, I think that's pretty much it. No, I think I need to hook up to the object initializer. They called it on Super, but let's see first, unless I'm mistaken. Actually, put that and that, and I need to have the special constructor for this, because I need to call the super for the object initializer for this for interfaces anyways. So const class and f object initializer. Oh, okay, so it's not giving me all of the hints that I need. Okay, thank you. I already typed it, and then it should. Okay, object initializer. Okay, so this is beginning to feel like an exam. And then, although I would guess in exams you have access to Google, but we're not going to use Google for this. This is still in the realm of pretty basic stuff, considering. So object initializer, yeah. And then, I think that's it. So we're just calling this special constructor. Then That should be a basic interface from within C++, unless I made a mistake, which it looks like I did. All right, so no include file. Yep, I forgot. You need the as the last thing here, because we're doing the generated stuff. I think it's automatically added, yeah, in here, but not when you create something from scratch. So we're gonna do, I think it's called CPP interface. The file name is CPP interface, right? And then that generated .h. So it's just a convention from Unreal here. We need to, not really from Unreal, but okay. So we have that. So we need the generated header files coming out of all these macros that we have, I believe. Come on. All right. This I feel should work. Yeah. So it looks like it's going to go through. Yep. So then you have a basic interface. So you need to have the generated, which if you can't remember, is something like this, automatically added for you by Unreal normally, but we're starting from scratch. You need that if you're using a lot of generated bodies here, macros. Sorry, class Livestream API. Then you need to define a blueprintable interface. Sorry, stifling a yawn. and then you need like a dummy class to hold it, and then an interface, the actual interface with the definition of a function that you need. So kind of like this one, you know. So we're just doing this one at the moment, which is the definition for the interface. And this one is kind of like this. Think of it as something like the dummy actor, which it's connected to. And this is an empty implementation of it, where it calls the super. But you don't need to know the full technical details. Just know that you need to call a special constructor for interfaces like this. All right. You can of course read up to it on the API documentation as well. All right, but that's how to create a basic C++ interface, which then you can attach to either blueprints or C++ classes. So basically, you'll do a multiple inheritance to do it from C++, but I want to keep that separate because it's a new concept, and I kind of want to do some visuals similar to something like this. All right, and yeah, it's already kind of noon, and I want to wrap this up. So we've got that running. If we run the project now, okay, so I seem to remember more than I thought I would remember. Okay, but it's still helpful to just, yeah, instead of, you don't really need to remember all of it. You just need to, but what's important is you understand the concept and how they're pieced together, the exact syntax. As is with most programming languages, it's usually, you know, not everyone remembers everything, especially with a lot of macros from UE4. So it's better to just have this defined in your own code snippets, or if you have Visual Assist, yeah, add it to the snippets in code Visual Assist. It's just so that you don't have to remember. It's as long as the important thing is to know how and why they're pieced together. So that's the most important part. Okay, so we've got the interfaces. And what did I call it? C++ interface? Right, so now you see that we have the C++ interface here. You open it up, it will open. Sorry, I didn't mean to double click that, but I accidentally did. Okay, so we're gonna implement that on here, on the cube blueprint, and I'm hoping that the Visual Studio actually doesn't load quickly enough. Alright, so you could see that from here on the class settings, we've implemented the BP interface. Let's add another one, CPP interface, right? and then what did I say? So you can do CPP interface, I guess. What was the event name? I forgot. Now I have to close this darn thing. Yep, and then what was my implementation? Oh, it's also respond to gaze. Yeah, so respond to gaze, it's this one, the one in the VR. So VR, what is this one? This is from BP interface, and this is from CPP interface, and that's what we need, right? I'm not sure why that is. Okay, because we've named it the same way, let's just remove this one. Let's remove the implementation for the blueprint. Let's remove the blueprint. So we now only have the CPP interface. Okay, so then we can do something the same. Print string. Low from a CPP defined event. Okay, so define interface, right? So that's what it does, and we need to call it from the pawn as well. So if you remember, all right, so let's not call it from here, let's call it from C++. Actually, we should call it from here to keep it consistent. All right, so let's call it from the out-hit actor. And since I know on the C++ side, I already check if it's valid. So this would always be valid every time this is called. So it's fine to use it. But of course, if you want to be 100% sure, you can do another is valid there. But in this case, we won't need to. So we need to just do a call to the what? Respond to gaze with VR. It's a message. Yep, there you go. So using interface CPP interface, right? And that's it. So now we should have the implementation running. So we've implemented it in, yep, there you go. So hello from CPP defined interface. All right, so we've covered all the topics we wanted to cover today. Ideally, I would have wanted to do a lot of, to show you in VR, the testing. And I've set up actually my Vive for this stream, but then I have to now fix my, I guess I have to fix Windows 10 on my VR rig now. Don't know what happened. I updated a couple of things in there this morning, so that could have been it. Okay, so I shouldn't have been doing that. But anyway, we got there. Might consider doing a restream of this with the VR interface, but basically you'll be doing the same things again. So, but do let me know if you want me to redo it for VR. But I will redo it on my own as well, so that I could update the source code in GitHub. Here, I'm gonna just put a note here today that there was a problem with my VR gear, and I have to do the live stream from a different machine, from my backup machine, and I only had 4.18 preview, so I'm not gonna upload the code in there. All right, so, and yeah, so, and that's basically all of the topics I kind of wanted to cover today. For the next stream, on your own challenge, what you can try to do, or if you want to implement, is do something that keeps track of a float variable. So you could use the delta time as a hint to kind of show, like on my plugin, like what I showed you how my plugin does it. It shows you a percentage of how long they've been staring, they've been gazing at something valid. So you're gonna need the delta time, you're gonna need a current time, current duration actually, and you're gonna need a current duration, and you're gonna need of course a max duration to be able to calculate the percentage. So just try to do this on your own. So there's no new concepts to know just to find this, or yeah, so it's mainly just doing all of the algorithms and knowing where things are, which is the important thing, and that's why I kind of want to do this as a challenge for you guys, for you folks out there. All right, so for the next stream, it will be the Mega Jam. Let me open that up. Mega Jam. So is it this one? 2017. That's really interesting. It doesn't come up. Let's do it manually. So I'm gonna go through that, and so we're almost done, folks. It's just I want to go to the forums, show you the events. Okay, and yep, 2017 Epic Mega Jam. All right, so Amanda has posted this one, and there's a CrowdForge IO for looking for teams, and I'm gonna be joining this week-long. So I've cleared my schedule for this. So it's always nice to join jams to kind of hone skills, and it's also fun. And yeah, so I've got a team of 3 at the moment, and we need 2 more. So I just want to take this opportunity to can ask you guys if you are an artist or a sound designer or a games designer. It'll be really cool if you can kind of join our team. It's also there in CrowdForge. Don't know if anyone's signed up. I haven't used this one for a bit. So yeah, so kind of, yeah, if you want to find someone who wants, and you want to do VR, and you're knowledgeable in audio, art, or games design, we need you. So thanks. Anyways, that's it for now, and thanks for on the next stream. I might do some live coding as part of the jam. So no specific topic, but for that jam. And as I mentioned, I might redo the this stream so that I have a headset and I can kind of demo it live. All right, so but that's a maybe, right? So, because most of the core concepts we've gone through here already. All right, so I'll see you next time. So the next stream will be the 5th of November. All right, thanks folks, and thanks for tuning in, and thanks for staying tuned in even though we had a lot of some technical issues with the VR gear. So hope we were able to follow it. Any questions, do just let me know. All right, so cheers and thanks.